What if a tiny steel ball could teach you how mechanical clocks were invented? This is a tiny steel ball. When it rolls through a straight groove, it takes exactly 1 hour. But if you wanted to measure 2 hours, you'd need another groove. And if you wanted to measure very long periods of time, you'd need countless long tracks, which would be extremely inconvenient. So you curved the track into a circle and divided it evenly into 12 sections, marking each one with a number. Wherever the steel ball stopped represented the hour. Just like that, you invented the earliest version of the hour hand. But 1 hour was still too long for precise measurements, so you divided each section into 5 smaller parts, creating 60 divisions around the circle. Then you added a second ball and made it move much faster than the first. By the time the first ball moved one section, the second ball completed a full lap. That meant every small division the second ball passed represented 1 minute, the minute hand. Then you added a third, even smaller ball and made it move 60 times faster than the minute hand. Every time the minute hand moved one division, the third ball completed a full circle. This became the second hand. So how do you read the exact time? For example, at 5:30:08, the hour hand ball sits between 5 and 6, the minute hand ball points at 6, and the second hand ball points to the 8th mark. That gives you the time, 5:30 and 8 seconds. To make all three hands move in perfect proportion, you designed a gear system behind them. The second hand gear had 60 teeth. Every full rotation of the second hand moved the minute hand forward by just 1/60th of a turn. That means the gear ratio between the second hand and minute hand had to be 60:1. But building this directly would require a gear with 3,600 teeth, far too large to fit inside a clock, and the hour hand needed an additional 12:1 reduction, which would require a massive 43,200 tooth gear. So instead, you attached a small 10-tooth gear to the second hand shaft and used it to drive a 60-tooth gear, creating a 1:6 reduction. Then you attached an 8-tooth gear to that same shaft and used it to drive an 80-tooth gear, creating another 1:10 reduction. Together, these two stages created the exact 60:1 reduction needed for the minute hand. Then you added 2 more reductions, 1:3 and 1:4, to achieve the 12:1 ratio needed for the hour hand. This allowed the entire mechanism to stay compact enough to fit inside a clock case. Even though the number of gears increased, each gear remained small and efficient. Finally, if you connected the whole system to a wound spring for continuous power, congratulations, you had just invented the mechanical